This question is about the photoelectric effect and the emission of photoelectrons. So if you remember, you shine a source of electromagnetic radiation, which could be UV or visible light, onto a metal surface, and then that may result in the emission of photoelectrons if the energy of the incident photons is greater than the work function. This question asks us to make a comparison between two different situations. So the first situation it talks about, and then it makes a comparison with the second. So the wavelength of the light is halved. So we get some photoelectron, then we halve the wavelength. Now bear in mind that halving the wavelength actually doubles the energy, because wavelength is inversely proportional to energy. So halving the wavelength effectively doubles the frequency, so we double the energy. But then it says the energy incident per second is kept the same. So for that to happen, for you to have the same energy per second, but each photon has twice as much energy, then you've got to have half as many photons incident per second. So we've got half as many photons incident, but each photon has twice as much energy. So the maximum kinetic energy of the emitted photoelectrons, the maximum kinetic energy is given by maximum kinetic energy equals HF, the energy of the incident photon, take away the work function. That will give you the maximum kinetic energy. So HF has doubled, the work function will stay the same, so the maximum kinetic energy has to increase. So that has to increase. That now we're down to, it can only be A or C. The second one is about this, is linked to the idea that the energy incident per second is kept the same. Now, if it's kept the same, we've got half as many photons. Now, one photon releases one electron. If we've got half as many photons, then we will release half as many electrons. The number of electrons emitted per second will fall because the energy is kept the same. So we have a much lower number, so about half as many photons incident per second. So the answer for that one must be C.